In this video, we're going to discuss one sample test of hypothesis. So let's take a look at the question. A marketing researcher wants to estimate the mean savings realized by shoppers who showroom. Showrooming is the practice of inspecting products in retail stores and then purchasing the product online at a lower price. The population mean is 58 with a standard deviation of $12. A random sample of 150 shoppers who recently purchased a consumer electronics item online after making a visit to a retail store yielded a mean savings of $60. So now we have two questions. The first, is there evidence that a population mean savings for all showroomers who purchase a consumer electronics item is greater than $58? And we'll be using a significance level of 0.05. And part two, we're going to look at the p-value and interpret its meaning. So the first thing we want to do is take a look at all the variables given to us so that we can then determine how to approach this problem. So we can see that we have a population mean of $58 and a population then standard deviation of $12. So there's our population variables. Now we can also see that we have some sample variables. We have a sample of 150 shoppers, and that gave us a mean savings of $60. So let's go ahead and write down the variables we have also in Excel so that we can then calculate things once we get to that point. So we have a population mean of $58, population standard deviation of $12. We then took a sample of 150 shoppers that gave us a sample mean of $60. Okay. Now the next thing we want to do is write out our hypothesis statements. So we have the null, hold on a second here. Fix this. So we have the null hypothesis statement and the alternate. Now always start with the alternate statement, as the alternate should answer your question. That's where the question lies. And the question is in part A right here, asking us, is the mean, so there's the key variable we want to watch out for, is the mean greater than $58? That's the actual question. Now remember, you always use population variables when you're writing out your hypothesis statements, which means you're typically using Greek letters. So in our alternate, we're going to say, is the mean greater than $58? There's our question. Now everything else falls to the null. So if the mean is greater than $58 in the alternate, then the mean is less than or equal to $58 in the null. And remember that the equal sign, whether it's tied with an inequality sign or not, is always in the null. Now the next thing we need to do is determine which distribution we're going to use. In this case, we can either use a z distribution or a t distribution. The question you want to ask yourself is, do we know the population standard deviation? In this case, we do know the population standard deviation. It was given to us in the problem. It's $12. And so we are going to be using a z distribution. If we did not know the population standard deviation, that is when we use a t distribution. So I'm going to go ahead and draw our normal curve right here, best that I can. Now in the middle of our normal curve is 58, because that's our mean. And what we want to know is it greater than 58? First you need to determine, is this a one or a two-tailed test? A two-tailed test has an equal sign and a not equals sign in the alternate. In this case, we have inequalities, and the question is it greater than 58? So greater than 58 is to the right of 58, which tells us it's going to be a one-tailed test to the right. So the tail on the right-hand side, I'm going to go ahead and shade in. Now the question also tells us to use a 0.05 level of significance, so the area under the curve should be 5% of the curve right here. So this is 0.05. At this point, we need to figure out what's our critical value. Now on a standard normal curve, the mean is 0 and standard deviation is 1. We know that 0 sits with 58. Now we need to figure out, for 0.05 in the tail, what is the z-score that sits right here? What should that be? To do that, I'm going to go back over into Excel. We're going to use an Excel function to determine this. So I'm going to look for the z critical value. And I'm going to use our insert function button up here, this f of x button, to figure that out. Now, there are a lot of Excel functions, and I can't keep them all straight half the time. So most of the time, I just search. So I'm going to say, okay, I want a normal distribution function. And it gives me a whole bunch to choose from. And it gives you the definitions down here of what's happening and different kind of things that you need. Now, I know that I want to put in a probability, and that's really all I want to put in. So I can see this one needs a mean and a standard deviation, so that's not it. This one also needs a mean and standard deviation. So you can click through these, see what you need. This norm.s.dist is where you put in a z-score, so that's the opposite of what I'm looking for. Now I know, because I've done this a lot, that I want the norm.s.inv, and see how it just wants a probability. That's all it needs. So I'm going to hit OK. Now the probability I'm going to put in is associated with 0.05. Here's the thing you have to remember though. In Excel, when it talks about your probability across the curve, it starts on the left and moves towards the right. And so what I actually want to put in is 0.95. When I put in 0.95, I get 1.64. Now, if I had put in 0.05, because that's the alpha that was given to us, I get the negative 1.64. That's giving it on the left side of the curve, because remember it starts on the left and moves to the right. So drawing a picture will really help you make sure that you get the right number, because you'll see that negative 1.64 and say, oh, that's not right, that's the left side, I want the right side. It's a nice thing about the normal curve being symmetrical. So I'm going to put in 0.95 and hit OK. So I have a critical value of 1.64, if we just kind of round there. So I'm going to put that right here. So 1.64. What that tells me is that now when I solve for z in the test statistic, if it's greater than 1.64, that is when I reject the null, if it's in the tail that I've shaded in. Now I've determined we're using the z distribution, and so my formula that I'm going to use for my test statistic is z equals sample mean minus population mean over population standard deviation over the square root of n. So that's my formula, and let's go ahead and solve for that. Let me get back here to my mouse. Okay, so we've got the z test. All right, so start with the equal sign, and then we've got my numerator is going to be the sample mean. Sample mean always comes first, population mean second. Otherwise, you'll be on the wrong side of the tail. Once again, drawing a picture really helps make sure all of your things are in place. So sample mean minus population mean. We're then going to do our denominator. So divide by, I'm going to start another set of parentheses. So we've got population standard deviation divided by the square root of 150. And close that parenthesis, and then close the denominator. Okay, sample mean minus population mean divided by population standard deviation over the square root of n. All right, so hit enter. So we get a z test statistic of 2.04. If we were going to put that on the curve, let me get here a different color, change that. So 2.04 is somewhere over here. It's to the right side of 1.64, which means we are inside the shaded region. We're in the tail. Because we're greater than 1.64, we are going to reject the null and go with the alternate statement. When you're asked to interpret this, what you want to do is go back and read the question, and the question was, is the mean greater than $58? And now we want to state that by what we discovered. And so we can say that the mean is in fact greater than $58. Okay, so that was all the steps for the regular hypothesis test. We're in the tail, we rejected the null, therefore we determined that the mean is greater than $58. That was part 1. Now in part B, we need to determine what the p-value was, or is. So let me just give you an association here really quick. Our z-test right here is associated, the 2.04 is associated with the 1.64. That helps us determine whether or not we're going to fail to reject the null or reject the null. So 2.04 goes with 1.64. Now when we deal with the p-value, we do the same thing, except that we associate the p-value with 0.05, whatever our alpha is. So let's go ahead and determine our p-value. So p-value. In this case, what I'm going to do is I'm going to put in the z-score I just calculated, the 2.04, and what I want to know is, let me go back to drawing here for a second. What I want to know is if 2.04 is right here, what's the probability of being greater than that? What's this space right here? That's what the p-value tells me, okay? So we're going to use another Excel function to determine that. Okay. And you can type in normal distribution again. And this time, I want to put in that z-score I calculated. I want to put in 2.04. So if I go down here to norm.s.dist, you can see that I put in a z-score and I put in cumulative. So I'm going to hit OK. And in that z-score, I'm going to put my 2.04, and then in cumulative, go ahead and type in true. Now what I want you to remember is that Excel is going from the left side of the curve to the right-hand side of the curve. Is it okay? So I get actually 97.9% is what that's showing me. And what that's actually giving me, let me give it a different color here, is that's going from here all the way over to here. But that's not actually what I want. What I want is this right here. So what I need to do is subtract from 1. So right here I'm going to say, okay, what I actually want is 1 minus this. And that tells me that there's 2%, 0.021 if we round, over here as our question mark over here. Okay, so there's 0.02. So that's our p-value. Our p-value is 0.02. What I want you to realize is that at any time when our p-value, right here, is small, and when I mean small, I mean smaller than alpha, we also reject the null. So 2.04 goes with 0.02, and 1.64 goes with 2.04. And either way can help you determine whether or not you need to reject the null. You can either do it by using the p-value, or you can do it by doing the, in this case, the z-test. And that concludes our video for today.